Ever wondered how electric vehicles keep their batteries from overheating? Managing heat is critical for performance, safety, and battery life, and that's exactly what thermal management is all about. Let's decode the science behind battery and EV thermal systems. In the previous lessons, I have mentioned thermal runaway a couple of times, so let's talk about thermal runaway and what exactly is it. Thermal runaway occurs when the heat generated within a battery exceeds its ability to cool down. This imbalance causes the temperature to rise rapidly, creating a dangerous self-sustaining cycle. So here's how it unfolds. First, there is initial heat generation. Normally, a battery produces some heat during use, which is manageable, but in cases of overcharging, a short circuit, or a physical damage, the heat can build up to dangerous levels. As the temperature continues to climb, the internal materials like the electrolyte and the electrodes begin to break down, releasing even more heat in the process. This kicks off a chain reaction. The heat triggers further reactions which produces even more heat, creating a feedback loop that fuels itself. At the same time, gases are released as the battery material decomposes, leading to a buildup of pressure inside the battery. In the worst case scenario, this can result in battery catching fire or even exploding, posing significant safety risk. Understanding thermal runaway is essential to prevent these extreme and hazardous situations. Now let's talk about the implications of thermal runaway and why it's such a critical issue. First, the safety hazards are substantial. Thermal runaway can lead to fires or even explosions. Batteries contain a high amount of stored energy, so when they catch fire, it's not like a typical fire. These battery fires are intense and hard to extinguish, making them a serious danger to both people and property. Beyond fire, thermal runaway can also release toxic and flammable gases, adding yet another layer of risk. These gases can harm anyone nearby and can create environmental hazards if not contained. Then there is damage to the equipment. When thermal runaway happens, it often destroys the devices powered by the battery. Think of a phone, laptop, or an electric vehicle battery pack. These are expensive assets, and thermal runaway can lead to a total loss. Plus, any explosion or fire can cause collateral damage, spreading to nearby objects or structures, leading to even more destruction. The stakes even get higher in electric vehicles and energy storage systems. In EVs, thermal runaway is a critical safety concern. If it occurs while the vehicle is on the road, it can lead to catastrophic failures, posing serious risk to drivers and the passengers. For large scale energy storage systems, like those used to power buildings or stabilize the grid, thermal runaway can trigger massive fires. These fires are incredibly challenging to control due to the scale of the system and the amount of energy stored. So there are preventive measures designed to help mitigate these risks. With the right thermal management strategies and safety protocols, we can reduce the chances of thermal runaway and protect both people and equipment. If you found this useful and want to learn more about how EVs, batteries, and energy storage systems manage heat, check out the full course in the description. Don't forget to subscribe for more insights into EV thermal management, battery tech, and cooling strategies.